We're in Algebra 2 at 9.7b. If you haven't seen 9.7a, I really recommend you watch that one first, okay? We're going to find x-intercept points using the quadratic formula. 9.7a helped us figure out how many x-intercepts there were. You can click on this video's description and watch the previous videos if you get lost or confused. The x-coordinates of the points where a graph crosses the x-axis are its x-intercepts. And these are the points where y equals 0. So if you look at this graph right here, you can see there's two x-intercepts right on the x-axis. Y equals 0 at those points. And to find the x-intercepts of a quadratic function, like the function of x equals ax squared plus bx plus c, we solve the equation 0 equals ax squared plus bx plus c. Now be careful. The x-intercepts may not exist at all. If the discriminant is negative, there'll be no x-intercept. All right? We saw that in the last video. So we can find the x-intercepts of the graph of the function of x equals x squared minus 2x minus 2. We solve the equation 0 equals x squared minus 2x minus 2. We use the quadratic formula. So we know the discriminant is underneath that radical sign. It's the radicand, isn't it? It's the b squared minus 4ac. All right. So what we do is we take our values. We have a 1 for an a value, don't we? We've got a negative 2 for our b value and a negative 2 for our c value, and we substitute them into the equation, into the formula. So because we have a negative 2 for our b, that means, because that's a negative b, we have a negative of a negative 2, see? Plus or minus our negative 2, our b value squared, minus 4 times our a value, which is a 1, it's an invisible 1, isn't it? Times our c value, which is a negative 2. It's going to be divided by 2a, and because our a value is that 1, it's going to be 2 times 1, isn't it? So now we know the negative of this negative, it's going to give us a positive 2, plus or minus the square of negative 2 times negative 2 is a positive 4, minus 4 times negative 2. See? That's going to give us a 4 plus 8, because this negative 4 times negative 2 makes a positive 8, doesn't it? And this can be broken down as 2 times 2 times 3, can't it? This 4 plus 8. Should be over a 2, shouldn't it? Oops. That means we can pull one of the two values out of the radical sign, like this, and we can simplify this. This 2 divided by that 2 is a 1. Plus or minus, we get another 1, so that's an invisible 1 that's in front of the radical sign, isn't it? The square root of 3. Now, because that's plus or minus, our x-intercepts are 1 plus the square root of 3 and 1 minus the square root of 3. And they occur at the points 1 plus square root of 3, 0, and 1 minus square root of 3, 0. See how we did that? So all we needed to do was to put in our a, b, c values into this quadratic formula, solve it, and we saw where our x-intercepts were, okay? So as we said in the last video, if the discriminant is positive, the parabola is going to have two x-intercepts, and if the discriminant is 0, the parabola will have one x-intercept, and it'll be at the vertex of the parabola. If the discriminant is negative, it's not going to have any x-intercepts. So we can find the x-intercepts, if they exist, for this one. We've got the function of x equals x squared plus 8x plus 16. We solve for this equation, and we just put a 0 instead of the function of x. See that? We have our a value, that's a 1. Our b value is an 8, and our c value is a 16. We put it into the quadratic formula. Here's our a value, our b value, and it's here also, and our c value. So because our b value is an 8, we get a negative 8 plus or minus the square of 8 squared minus 4 times our buddy the invisible 1 times 16, and that's going to be divided by 2 times our buddy the invisible 1, the a value. All right? So now we can start simplifying. That's going to give us a 64, isn't it? And 1 times 16 is 16, and negative 4 times 16 is a negative 64. So we've got 64 minus 64. Well, that gives us a square root of 0. And the discriminant is 0. The parabola has one x-intercept. When we simplify this, negative 8 divided by 2 is a negative 4. That's its vertex. We've got one x-intercept at negative 4. See? It's just knowing your a, b, and c values. All right? Let's try this one. We're going to find the x-intercepts if they exist. We set our function to equal 0. We've got a negative 2 for a, a negative 4 for b, and a negative 3 for c. So that means for our b, we've got a negative times negative 4 right up in front. Let me grab this so we can, let me put this here for you, so we can compare, all right? So here's our b value. We've got a negative of a negative 4, all right? That's going to give us a positive 4 down here. It's plus or minus the square root of b squared. Negative 4 times negative 4 is a positive 16. It's going to be minus our a value times our c value. And our a value is a negative 2 times a negative 3c value. That's going to give us a positive 6. It's got to be divided by 2a, and our a value is a negative 2, so we've got that there. And that's going to give us a positive 4 plus or minus the square root of 16 minus 4 times 6. Well, that's 24. So we have 16 minus 24. This is going to be a negative 4 for our denominator. Now, 16 minus 24 is a negative 8. So we've got 4 plus or minus the square of negative 8 divided by negative 4. And because that discriminant is negative, there is no x-intercept. There's none. That's the answer. All right? So it was negative. And in our rules, if the discriminant is negative, it's going to have no x-intercepts. Okay? That wasn't too bad, was it? Our next video, we're going to talk about how to find quadratic functions from the graph or 3 data points. I'm going to add this video to the Algebra II playlist. I'm going to have the 15 previous videos that we've done so far for Chapter 9. And that one we just did, 9.7a, where it talked about how many x-intercepts there were using the discriminant, okay? All you have to do is click on the description and you can watch that. So if this was helpful, don't forget to hit the like button. I really appreciate it. And don't forget you can support me on patron.com and donate $1 or $2 each month. And I'll see you next video. Have a great day. Bye.